Wait. Go, go to sources. Click on sources.
Yes, ma'am.
Can you show me your GeoServer ones for the NDVI and the reclassified layer? Nothing is changing, Madhubala. Are you changing anything?
No, ma'am. Layer preview.
We can't see your screen, Madhubala. Oh, shelf left. Okay, fine. So by the time she's joining, we'll check on the query later. In today's session, we'll start with the Open Data Cubes and AWS Data Cube session. Just let me share my screen. Okay, is my screen visible? Hello, am I audible? Screen is visible, everybody?
Yes, ma'am.
Okay. Okay, so in today's session, we'll understand about AWS Open Data and Open Data Cube, which is the part of, I will say, cloud-based data storage and cloud-based data analysis part. And mostly AWS Open Data and Open Data Cube is used for production grade analysis when your work is not limited to maybe a 10 years or a decade of time series analysis. When you have to do work with big data and there are a lot of data sets, lot of files that are involved and which you have to process, so AWS dataset is the kind of platform which helps you fetch the data from the Google storage. You can say that it is kind of like a Google Earth only, like, or the Google Earth that we have seen, Google Earth Engine, where we try to fetch the datas which are hosted on the Google Cloud services. We were processing it, doing the time series analysis and everything. Similarly, there is another platform like AWS Open Data, where all the data they have stored, Sentinel, set NDVI, or land cover land use data, means there are a lot of data which they have already pulled in. Then there is another thing which is called as Open Data Cube. So whenever we name something as open data, means data cube is involved. So means we are not talking about a single timestamp, or we are not talking about a single parameter. Just with the X and Y, means along with the pixel information. Now time also became a part of your analysis. Okay. Madhubala, we will see your query no, after this.
Okay, ma'am. No problem. There was some internet issue. That's why it was disconnected. No problem.
Okay. So moment we are terming as a cube, means we are talking about a three-dimensional analysis. Means time also comes into a picture. Means you are storing your data in such a way, like till now in whatever like platform I have shown you. everywhere we talked about only the 2D thing. No, in no places I have talked about how to store or how to manage a 3D data where you have time also in the picture. Even in the Postgres is a database where you keep or organize or assemble, structure your all geospatial data sets. But there also we haven't talked about any provision that how can you manage your time space data as well. So Open Data Cube is a kind of a platform which helps you with big data management. Whenever I say big data management, we will never, or I'm not talking about 10 satellite imageries or 20 satellite imageries. It will be a tons of satellite imageries, maybe 300,000, 2,000. We are talking about ample amount of data. Along with that, time space will also come into the picture. So data cube will be combining of X and Y, means the pixel information that we have already understood about how the raster data is, and then time also become a part of it, and obviously bands means the spectral layer, means a single raster layer, maybe it is an anywhere layer or it is a Landsat layer, then it can consume 10 bands, 20 bands, 20 layers of information, and then also time is also a picture, means it is a 20 years of data or a last 50 years of data, or like any like decadal information is stored as a data cube. Open Data Cube is an open source framework, means it is not a paid version, which is designed specifically to organize and analyze large amount of Earth observation data. Though we don't actually perform analysis, but it's just a way, like in the pgadmin, if you look at it, how we store data in a Postgres interface, we only store the data, and the only analysis and few syntaxes and few functions that are available with it is to just analyze and understand how the data is stored in PostgreSQL. So simply here as well, whatever if I'm saying analyze large amount of data, I don't really mean calculating ndvi and doing trend analysis. I mean just understanding how the data is structured and organized within the Open Data Cube. We will not be storing any data which is small and which is not time specific in the Open Data Cube. Mostly Open Data Cube datasets are used for heavy analysis, model training. Let's suppose if you understand about this, like Google also opened a platform where they are giving you land use, land cover analysis for last 10 years, 20 years. So how do they actually do it? So they are actually computing a Open Data Cube. In maybe in their private interface, not in the open platform phase, but Open Data Cube is a way how you can openly access it freely and create a data cube for your time series analysis, create a sample out of it. Like maybe in the next track, actually, when you understand about machine learning and when you understand about training the data, training the samples, creating predicting the output for a 10 years, for the next 20 years when you're predicting the output, so you actually have to understand the trends, how it used to happen in the last 20 years, last 30 years, and then you will be predicting the results. So how will you actually store and manage those last 20 years of imageries? How will you manage such large scale of sample data that you might have? So, and when you are working on a production level, not just for learning, like right now when we are learning, so we'll be maybe practicing with a small set of data sets. But when you are actually working in the large scale, think of like how they are actually training a chat GPT model data or something which is on a large scale. So they must be storing somewhere in some kind of a framework. So ODC is such kind of a platform which helps you store big data, helps you compute multi large scale imageries, helps you create samples, training data set, and also analyze and gives you a trend analysis and ultimately give you a output at the end. What is so that was about the overall about the ODC. We'll see much more things when I'll show you in the docs and everything. How the AWS Open Data is different from the ODC. ODC was the platform which helps you for data management and analysis, means it is just a way to store things and organize things. Kind of like not similar to Postgres, but kind of like a Postgres thing for a heavier data. AWS Open Data is just a platform where data are stored, not in a queue format as a raw imagery format. Means Amazon Web Services, they host massive public data set under their Open Data program. Satellites, imageries, Landsat, Sentinel, Modis, and whatever you can think of, they have all the data set available. Like in Google Cloud, they have all the data set available. Similarly, in AWS Open Data as well, everything is available. The why actually AWS Open Data comes into a picture when we are talking about ODC, you can say that can't be accessed from the Google Cloud. Actually, Open Data, AWS Open Data is highly compatible with Open Data Cube, with their APIs and everything, and how you can link both of them together. So how they are actually stored in the cloud. No download is needed if you're trying to access AWS Open Data into a Open Data Cube platform or into a direct Python access. Ready for scalable analysis. Obviously, if it is not down, no option of download is available, you can export and everything, but you can directly access it via APIs and perform your analysis. Usually, all AWS Open Data is stored in a something called like a S3 buckets. This is called like a cloud storage which they have. They have named it as a S3 buckets. It's not limited that you only have to use AWS Open Data to work with the ODC. You can use any third-party API wherever the data is accessible, and you can access it and utilize it and create a data cube and work with it. It's just they have created an extensive amount of data set with all kinds of imagery in a proper format with the metadata and all the things that are necessary for creating a data cube. Provide direct access via internet or API. Same thing, it is accessible via API or URL, no need to download. And AWS Open Data does not analyze the data. As I mentioned, you will not be able to analyze the data. It's just a way to store the data in that. Then analysis will happen afterwards, means after you access the data from AWS. Do not get confused here. From AWS, when we access any data, in AWS, it is stored like a raw TIFF file kind of a format. A raw data is stored. When ODC comes into the picture, Open Data Cube comes into the picture, we fetch the data from AWS Open Data or from any other platform from where we get multi-satellite imagery, multi-year satellite imageries. Then we store it, we index it properly, organize it, create a data cube, and then ultimately fetch it in the Python for doing our analysis, maybe NDVI analysis, a climate analysis, a wind analysis, or a land or a temperature analysis, or any kind of analysis later on that you can perform using that data. There is another way that you can skip the ODC part for a smaller scale of studies. When I say smaller scale of studies, usually ODC setup is very complex. You have to install the system on your desktop. You have to set up it. That we will also not do it in the session. That is for production grade style that you are accessing and setting up ODC. But I am just giving you a context that something called ODC is there, so that if somebody asks you a question, you can say that I am aware about what ODC is, how actually you should know that how you can read the documentation, and you have an awareness about what ODC is, and later on in interviews question you can simply put it like that mostly it is used for production grade styles. So whenever in future needed, whenever I'll get a chance to work on it, I can work on it because I know what ODC is, I know how to read its documentation, what all things are there. You should know all these things, but will not do the setup. So the second part is, can you directly access AWS data and temporarily create that cube and perform the analysis? Yes, we can do that. And that demo we will do in this session as well. Means the ultimate agenda is to create that cube from that multi-satellite, multi-year satellite imageries and perform analysis, a trend analysis, a time series analysis at the end of it. Google Earth Engine was the easier and the quickest method that we have already seen. ODC is the production grade, bigger, complex, or you can say it will help you analyze 30, 40 years of single imageries in a quick way, in an organized way, and everything. AWS is just like a platform where data is hosted, which is most compatible. I will not say the only platform which is compatible with ODC, but the preferred and the most compatible with ODC. So once you fetch any data from AWS, we use in production level, we bring it to Open Data Cube, we index it, we organize it, we structure it, we create a cube, and then later on access and create a analysis, maybe an NDVI analysis. But for normal, for quickly, we can directly fetch the data from AWS. We can, on the fly, we will generate the cube. We will not store the cube in some place as a static. We will generate the cube and then perform the analysis and get away with it. Have you got the difference between AWS Open Data and Open Data Cube till this point? Any question in this till this part? Anybody?
ODC is where we can analyze, right? And
Sorry. Yes, ODC is where you actually create your cube, not just analyze, not analyze, where you'll store your cube based data. Means let's suppose you have all TIFF files, maybe 1,000 TIFF files. You create a time space cube data and you store it in ODC. So ODC will help you to only store and structure and organize that data. Simply like a Postgres. In Postgres, we only store that data. Analysis ready data cube. It will convert raw satellite imageries into analysis ready data cube. We don't do analysis into Open Data Cube, though there are platforms later on. Simply, if you look into this code, so this is like we are kind of accessing the data and then trying to work with it. Time series NDVI analysis, we will do it using the Python only later on, just by accessing this data cube that you have created in the ODC. Similarly, like in Postgres, we can query the data from the table, but can you do the NDVI analysis? Can you do the time series analysis in Postgres? No, we cannot do it, but we can access what the data is stored, how it looks like, how it behaves. Little bit information we can also analyze within that also. So you can simply relate with Open Data Cube as well, that it helps you query the data by time, by the location, and by the spectral band, because this is the only information that our Open Data Cube will contain. Three-dimensional data, a time will be there, latitude, longitude will be there, and the layer of data means stack of bands which you have stored in that information will be there. Okay. Okay, so this is just, there are multiple libraries which are available to access AWS data directly into the Python. So this Boto3 is also one of the library that is available to access the data. We'll see other libraries as well. So simply now how you can access the syntax and everything will not gonna change. How we work with Python and everything, the loops, that is not gonna change. The only thing that you have to know is about where you have to access the data. You have to know your keys, you have to know your URLs and all those things. So we can directly access the Open AWS data directly into the Python with various libraries that are available in the market. They keep on changing. So that is why I haven't mentioned any specific library at this moment in this tutorial. And I will not even specify that this is like, unlike in Python, we discuss GeoPandas, we discuss pandas specifically. Deliberately, I have not specifically mentioned that you should use Boto3 library, because they keep on changing as per the requirement. They keep on updating, because AWS Open Data and ODC is all about open source, and it's all about cloud storage thing. So they quickly keep on changing. Even the URL, even the keys, everything keep on changing. So that is why I haven't mentioned anywhere any name of the specific library that you should use only this, or this is the key which will work. Maybe right now I just put this screenshot for a reference, but maybe it's quite possible that even S3 can change in future. So the only way forward will be for you is to understand what is ODC, what is AWS, and then when we'll come to the doc part, then I will make you understand how you have to read the doc, how you have to access things. So at this moment, when everything is accessible by a click of search, so you only have to know how to read these documentation pages. And when they are updating something, every time when you're working with it, maybe even after a month, you come and you think that, okay, I have to work with Open Data Cube, I have to access something from AWS. Should I refer the same PPT that I might have shared a month earlier? You will not be able to refer the same keys and the same URLs because they keep on changing. So you have to come back to the doc part only. You have to access everything from the documentation. So earlier as well, I mentioned, start referring the official documentation of everything. And especially for Open Data Cube and AWS, you have to refer documentation for every URL and every key that you might need for accessing and doing your analysis. We will understand about the architecture and how you have to link and everything that we will see. Okay, so example satellite data sources. So all satellite data that you might think of, MODIS, Landsat, Sentinel, everything is available in AWS as well. You can get this after exploring in this. Then how ODC and AWS work together. So first of all, let's suppose you have a AWS Open Data. That is just a platform to store the dataset, raw imagery of dataset. No processing has been done with that data. It is just stored as it is. Like you might download a raw Landsat data from USGS. This is the platform, like a main platform to download the Landsat data. So how you download your satellite imageries from this Earth Explorer is simply what they have done. They have linked it from here to the AWS bucket. That from there also you can access the same data just by filtering the date and time. Simply like in Google Earth Engine, what they have done. AWS kind of a replica of Google Earth, how they have stored in that. So in this, mostly all the Sentinel and Landsat data are stored in the S3 bucket. So this can change, but mostly it will look like this: S3 colon dash dash and the name of the satellites and however the data is stored in that platform. So first of all, let's suppose you have accessed the data from the S3 buckets. Then when ODC will come into the picture, ODC index data. So like in the Postgres, we used to index the data. Here as well, we will index the data. ODC organize imagery into a searchable cubes. Means into a search, it will organize it properly, whatever time space and the band stack and the layers that you have given for that particular cube. Then once that cube is created, now your data is ready for query. So you can query that particular data by using the area, time, bands, and everything. So here as well, data cube library, we can directly access if you have created that cube in your ODC. Import data cube is the library by which we can access the data cube into a Python environment. And simply we can query that cube data by using the time, latitude, longitude, and the product information and all those things. And later on, once you access that data, we can compute NDVI or any other analysis that you might want to do with it. Because obviously, if you get the access to bands, if you get the access to band 4 and band 5, you can do NDVI. Similarly, for any other indices, if you want to calculate, we can do seasonal vegetation, drought detection, crop monitoring. Since this is a cube, so mostly we will be using it for analyzing the trend rather than computing it for a single or an individual analysis. Because if my agenda is only to do an individual location and an individual time frame of study, will I go to Open Data Cube? No, that is not recommended because unnecessarily I am just complicating things. I will simply go to the Google Earth Engine. I will filter out, I will do my analysis and I'll export and that's it. I will not do all this facade just for a single time analysis. I will only switch to AWS Data Cube and ODC whenever I have to do a multi-year trend analysis. That is, and mostly for training the data, training it for a ML model, or you are creating a model for 30 or 40 years of data sets, then only we'll go with this. Otherwise, we'll skip this part. Okay, we have seen this. So a few difference without Odyssey, if you're not using the Odyssey, you're only using AWS, we'll only get the raw file where it's hard to manage the time series analysis. Manual processing is needed for creating that queue. Without OWS, if I'm using only Odyssey platform, I'm not linking it with OWS. So I have to download all those multi-year of data set, which is a huge data locally, and then I will create the Odyssey. So I will not do that thing that I'm downloading all the data in my disk and then passing it to the Odyssey for creating the data cube. But the most powerful way is to Odyssey plus AWS combination, because AWS will help me with the cloud storage dataset. Odyssey will help me with the structured framework, and then I can create scalable geospatial workflows, and it will be most efficient for time series analysis, because that's the whole purpose of doing the cloud-based analysis, so that I can do the trend analysis and time series kind of analysis. So till now, I tried to build two kinds of approaches, like Odyssey approach, and then Odyssey is important, most beneficial, but we will not be doing the hands-on with the Odyssey, because the setup and everything is a complex, which is not needed at this moment for anybody, for any of you. If in case anybody really wants to do that, I have to install Odyssey and I really wants to do the hands-on, we will see that after, once you complete all your track. Whoever is interested for that, let me know, because Odyssey complete setup and everything needs at least 1 week of sessions for that. So if more than 5 people will be interested for that, we'll take that complete Odyssey session again, only for interested people. Then, so however, there are multiple ways to perform geospatial analysis, as we have already discussed in the last lot of session, like Google Earth Engine, and then we can bring it to the Python as well, link the GE API we can do cloud analysis as well. Then why actually we have discussed why actually Odyssey will come into the picture, so that satellite data is the first index into a database, so that you can index that data, create a time space cube, and do time series analysis on a scalable format. With Postgres, pgadmin is very much well versed with vector database. In that, we can host raster database, but in Postgres DB as well, there is no such platform, or there is nothing like which will help you create a time series data cube. So that's why Odyssey comes into the picture if we have to do the large scale repeated analysis on top of that. But even for the data cube as well, if let's suppose you have to do a data cube analysis, but quickly, just for one time, just for a single research project or something like that, then there is another way of doing is stack implementation. What stack approaches, it will help us build a virtual data cube dynamically using the cloud hosted data. In the stack approach, what this approach will do, in this approach, we'll skip the static creation of data cube and storing it in the Odyssey framework. We are virtually on the fly creating that cube, doing our work, and then getting away with it. I am not storing that cube as somewhere as a like a permanent way. I'm not storing that file. So a few difference between both the approaches. In stack approach, data access will be directly from the AWS. In Odyssey approach, we will fetch the data from AWS, but we will index it into the DB. So means in Odyssey, how we are actually getting the data? We are getting the data from the DB cube that is already indexed and that we have already stored. We are not accessing directly from the AWS as a raw file. Indexing in stack approach, we are accessing the data like what is the time, what is the pixel value, all those metadata information directly from the stack metadata information, not from anywhere else. Whereas in Odyssey approach, obviously we will create the metadata information, we'll index it, we will store it. So we will fetch that information from PostgreSQL. That is a complete setup of that Odyssey. Postgres will also come into the picture in Odyssey approaches as well, but not like what we have seen for the individual tables that we have stored. So there, once we will do the indexing, we'll store the metadata, we'll create a metadata file separately in Odyssey approach, we'll do it properly in that. Cube virtual on the fly means once you are fetching the data in the Python while you are coding, we will be creating the cube on the fly and doing our analysis and getting away with it. Whereas in Odyssey, the whole agenda is to create a cube and save it and store it and then access it later whenever required. Obviously, setup approach is very easy in Stack. There is no setup, I will say. Whereas in Odyssey, there is a complete setup altogether which comes into the picture if we have to use the Odyssey indexing based approach for our data. Query speed, it's medium because obviously you are creating the cube on the fly, so it will take a little while to create the cube of 300 files or 500 files. And in Odyssey, it will be very fast because you have already queried your data, already indexed it properly, already stored your cube. So it will just quickly give you and fetch you the data the moment you will query from that. So that is the reason for this demo. We will follow a cloud native approach that follow the same data cube principle, because obviously here as well we are creating ultimately cubes, but we are skipping the Odyssey deployment and everything here. Okay, so before moving into this setup, I have to show you the documentation of this Open Data Cube. Okay, so this is the main page of Open Data Cube documentation. From here only, everything else, when I redirect to those pages, this is the main page, and from here only, you will be able to access everything that you can do with the Open Data Cube. If somebody is trying to understand Open Data Cube for the very first time, this is the go-to thing where you have to go instead of roaming here and there. You have to come here, you have to understand what what Open Data Cube is, how you can analyze with this, how you can create different Open Data Cube in this, and how you have to set up the installation part, and everything is accessible here. If you want to go to the setup part, you can click on the setup. This is the setup. What are the different requirements? How you can set up, how you can download, how you have to install, what are the different upgrades that have already happened in this. So everything is available in this particular documentation one by one. Okay, so if you remember from the XArray session or the NetCDF session from our last track, yes, in the last track only, we have done an analysis of the NetCDF data. We have tried to do some rainfall analysis using that, and we have tried to see we did it using the XArray library. So if you think that how in the Odyssey all the data are structured and how they actually make that time series data. So they actually utilize on the background, they utilize this XArray library of the Python, and then they create labeled multidimensional array libraries. So for understanding how the Open Data Cube structure their cube altogether as a whole, you have to understand the URL that I have shared in that session of XArray, that how multidimensional array of how the multidimensional imageries are stored. So you can interchangeably say that Open Data Cube for any of the time series that you're creating is kind of a multi-dimensional imagery only. But the only thing is, in multi-dimensional array, there can be multi-parameter data. But here we try to create open data cube only for one single parameter. Even if there are stack of bands, we can store different information, like one band is an NDVI, another is some different indexes, another is different index. Like that, we can store all those multi-parameters in that. So kind of it is a representation of multi-dimensional array only. So that's why it is mentioned that it is leverage xarray Python package for implementing spatial temporal arrays. So ultimately, this open data cube is only array only, where you have brought the time picked into picture, and the space was already there, and multiple parameters in terms of the bands that we have seen here. That XY was the spatial, T was the time, and band is spectral layer. So you can all anyways treat it as an individual band information or multiple parameter that we have studied in multidimensional array. Then the next is, okay, we have already discussed this part. But you can go through all these documentation pages. I will add all these URLs into this Word document only, so that you can have more understanding about everything. This is the Git page of Open Data Cube. You can clone this particular repository and it will help you. All the setup, how we can set up the ODC, everything is present here. But if you are interested, then only go with the setup part. Let me know later if anybody is interested. Otherwise, just skip this part for now, because I don't think anybody will go to the Open Data Cube at this stage. But this Git repository is basically a whole guide how you can set up ODC in your own system. So this particular page is the updated I will say the updated version of Open Data Cube doc. The second one that I'm opening is the previous version of the documentation page. This was the older version, but ultimately more or less things will be same in both. Only the things that are updated will be updated. So you can install this on your system as well, the Open Data Cube software. Then we can prepare the data either from accessing from the AWS and then load data into the ODC. Everything can happen step by step in this. So I'll skip this part. We'll directly move to the tutorial part from this. In their documentation page as well, there is a tutorial. So first we'll go through with that tutorial and then we'll do our own tutorial as well. So from here, they have mentioned how you can access the ODCs from the ODC stack. The second approach that I discussed means without building the ODC data cube by doing the original setup. By skipping that part, how can we directly access and create the virtual cube and perform our analysis? So in this, what we are trying to do, we will use the impact of observatory annual land use land cover product, and we will, after loading the data, will export each year of data as a cloud optimized TIFF. So means you can export the dataset as well, and then using the PyStack client library will connect to this stack. So stack word that I was using a lot of time is spatial temporal asset catalog. So this is just a platform where your data is stored as a stack altogether. So there are multiple data sets that are available in this stack, and you can also access it from multiple platforms. Those platform are, this is the stack tutorial, how you can access the stack data. Lot of data is available in this. This is the catalog from this. This is the stack earth. No, this is not the earth one. This is one. So this is the stack earth data that is available. In earth data, all the Sentinel and Landsat data is available. Here you can see the catalogs are present. We can access this data directly using this URL. Then there is a Microsoft platform provider as well, which also helps us with API based data. Yes, Microsoft Planetary Computer, they also store a lot of data sets. So in their stack as well, a lot of data set are available, which we can access using the API. The AWS Earth search that I was showing just now for the stack is this URL. Then, yeah, this was the same. This is the user guide for the Amazon S3 product that I was discussing, that they store all the data in their S3 catalog. So this is the user guide URL for that. So if you want to get deeper into how AWS Data Cloud store this data, what is S3 bucket and everything. So you have to go deep into this user guide, Amazon S3 on Outpost. So this will give you a complete understanding about how in S3 buckets the data is stored and everything. What are the naming rules, and how you can access it using the URL. We will be using this Earth catalog data only for our analysis. Then again, this is again a ODC stack data that is available. There is a complete documentation how you can access this particular doc in your Python and perform your analysis. This stack is for coming from the Planetary Computer, means that Microsoft one only. This URL is for that Microsoft API URL, http planetary computer microsoft.com. So there is a complete documentation how you can access the data from this particular catalog. So it's not like that nothing is documented, that what kind of keys that you have to use, how you can filter. Even if they change this URL and even if they change how you can access the stack, you just have to search and you must get the official documentation. Always follow the official documentation because they keep on changing from this. So if you are doing it for the very first time, so you can just go through this overview that, okay, fine, how to load the stack. So I can load the stack using pystack.item, xarray.dataset, pip, I have to install this ODC stack first, and then other dependencies as well, it will show you. Then next part, there are multiple options using pip whenever you are using the Python in the Google Colab or in the Jupyter lab. We will be using pip for installation of the libraries. Whenever we are using Anaconda, we will be using Conda for our case. So you have to just know how to access this documentation as per if are you working with on Windows, are you working on Mac, or are you working on a Linux system. So few of the things will keep on changing on the basis of that. Then API references. So there are multiple APIs that are available. So one by one, so we will be using ODC stack only. So if you click on this ODC stack, all the functions that are available within this for all the specific basic tasks that are available in this. What in ODC.stack, how to load the item, how to configure, how to access, how to parse the item, extract collection metadata if you want to extract the metadata information. So everything is available in this. And then the use cases used to compute the output geobox for load parameters. If you have loaded any parameter and you want to pass that I want to access only for this bounding box, so you can use this output geobox. Similarly, other libraries are also available. Example notebooks. It will also provide you some few examples in this. Let's suppose, let me open something. So a basic example how we can use the library and plot it in this. So it has shown us this basic notebook is there, a sample notebook. So you can follow this notebook one by one, that how to get a result out of this and then work on your specific use cases from this. Okay. So you can see that there are three examples: Access Sentinel-2 data from AWS, Access Sentinel-2 data on Planetary Computer. This is from Microsoft. This is from AWS. So there can be many other options as well. They just have given the references for two. Access Sentinel-2 analysis ready data from Digital Earth Africa. So they also have some kind of a data. So from here as well, you can get the data. They have also shown you that what are the required package that you have to store, you have to import, how to set the collection, how to set the configuration and everything. But this whole documentation is only for the stack approach, not for the ODC approach. Query stack API. Here it just showed multiple your imports, then what is the URL, how you can query, what you have to give in the collection, date, time, then more information about that, then how to load different bands here. You'll get all your data as a multi-band, multi-dimensional array, X array here. So this is X array only. Then do math with the bands, means do your analysis, maybe NDVI, NDWI, or any kind of analysis that you want to do. And then at last, just plot it, whatever you want to plot. And after just you loaded, the only drill here is to load the data. After that, all the syntaxes that we used to do in the normal Python will go in the same way. If you know how to utilize the Xarray library or the ND, how to load the netcdf, if you know how to handle the multidimensional array, then it's easier for you. Then nothing is changed after that. That like here, nothing is there to explain. Nothing is new in this scenario here. For doing the math band, how to work with the arrays that you got out of a multidimensional array, how to plot with that output, how to do the NDVI analysis. This was same. We were doing it from the day one now. Plotting, nothing will change in terms of plotting. How we used to plot it with leaflet, with folium, with matplotlib, everything will be same. This whole documentation and then this whole thing was all about how you should load the time series data into a optimized way and how you can access the data without downloading it on your local drive and local dictionary. Okay. So that was about the stack and means how you can access different kinds of a data from Microsoft and from AWS. So these are the documentation for data only. Then this that I've shown you for the tutorial. In this tutorial, just okay. So in this, basically in this particular tutorial, what they are trying to do here is they are trying to access the data from this particular URL, which is Impact Observatory Annual Land Use Land Cover product, which they have. In this, what we'll do, we'll specify the data in terms of what data we need, what product we want, where we want, means we'll give the area of interest, we'll give the date range, means what kind of a, for which time period we need the data. We'll load this data into a data structure format, then we'll create a cube on the fly, and then we will obviously export, means visualize the result, and we'll try that how you can export that particular result. Then which library we'll be using? We'll be using PyStack client. Why? to connect to a stack endpoint and search for data matching or what, where, and when. So we'll be using this. Use ODC stack to load the matching data into a memory. So we'll be using ODC stack library to load the data that is matching with the data that we are trying to this, and stack also we are using to connecting to this particular stack endpoint that which data is there. We'll see what is the difference between PyStack client and ODC stack in this term. We'll see this. And if you are doing it for the first time, from here itself, you will get the option to open the link in the new window, launch tutorial environment. It will directly give you the access to this their.py file, their tutorial file, and everything will be there. You just have to click on this launch binder. Okay, so in this tutorial, everything is mentioned what you have to do and why we are specifying and what is we are doing. The only thing that we have to see is the difference between PyStack client and the ODC stack. Once you'll go through this, you'll understand. So PyStack client is only for searching, that will search it from the stack endpoint, search the data from there where it is located, time and everything. ODC stack will help you. It's like a what do I say, it's like a player, means it will help you to load the data into a queue format and process that data particularly. So if you look into the difference, PyStack client will help you connect to the stack API, search the metadata, retrieve those stack items. What it will give you as an output, it will only give you the metadata information like a image date, a cloud cover, or like band information, all those things. But it will not give you the actual array, I will say. Then if when once we'll use ODC stack, there are different libraries as well. We'll see both the libraries. So in this we'll use ODC stack, and there is something called Substack, which we will see in another tutorial. So ODC stack will help you read what is there in stack items, access the raster file, build the xarray data queue. So I hope the difference is clear between both the libraries. Similarly, like in Rasterio and everything, we used to open the raster file using the Rasterio. Then we used to convert it into a NumPy array so that you can actually perform any kind of a processing with it. So is the difference clear in both? Any questions? Anybody? Hello, am I audible? Okay. So then obviously we'll import the necessary libraries, GeoPandas, ODC.geo for exporting loaded data, and then ODC stack for loading the data, planetary computing to provide the authentication that is required, and PyStack client for querying the catalog of data. Then we'll set up the query parameter and everything, the area that you want, area of interest and everything. We'll load the area like this. And once we are loaded, we will also specify the date range, then stack metadata, what URL we want, what collection we want, what is the desired data that I want. Then I'll connect to the catalog and then find the item using the PyStack client here. Search for that item, load that item using ODC stack, visualize that data and export the loaded data. The tutorial is completed. That's it. Well, in the same, once you'll clone that URL of tutorial, once you'll build that using, you'll launch that tutorial, you'll get this tutorial. So you'll only get an understanding what is going to happen. If you'll go to the tutorial solution page, you'll get the code as well for this. So in this is the first import part. So I will run this. Import is done. Area of interest, AOI GeoJSON is already there. We know how to load the files, so we can load our area of interest. We'll specify date range, then we'll specify the stack metadata, catalog URL, collection and everything. We'll connect it using the PyStack client.open, pass the URL and everything. Now we'll search for that parameter and we'll load this GeoJSON as well and desired AOI geometry. And then we'll run this again. It found 7 items. Then we'll try to know what is there in that item. So feature collection, 7 items are there. We'll open. All the information is there. Bounding box is there. Collection in asset collection is present. Data is present. That's fine. Then now we'll load the data using ODC stack. We created a cube at this moment. Item is a list of stacked items to load. Band, a list of assets to load for each item. GeoPolygon for the area of interest. CRS, we already know, and the resolution. The resolution to load the item at in the same unit as the CRS means in which resolution you want to load data. Now we got a XArray dataset. It is a multi-dimensional array. The time period we gave is for 1st January 2017 to 1st January 2023. Then we will visualize our data. Plot for the 5 years. Sorry, more years. 7 years. From 17 to 2023. We got all the visualization here for that data that we accessed. You can also export it if you want, that for which you want to export. You can give the path and everything. I'm not running this because it might take time. But you can export the code and everything will be same how we used to handle in the XArray dataset. So there is nothing new in this. That's why I'm not over explaining the code part here. Everything how we used to do it using the XArray, it will happen like that. The only thing that you need to know in this, how to use the ODC stack library, how to read the documentation and how to link it with this and then perform your analysis. So that was a tutorial that they have. So you can directly access it from their platform. Then simply we'll do the tutorial for the NDVI as well. I'll calculate the NDVI analysis. For that, we will we can use our Google Colab. There we will install all the dependencies that are required. So pip install PyStack client, Rastereo, NumPy, Matplotlib, Substack. So instead of ODC stack, right now we will be using stack, 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 STACK and STAC library for creating the cube. So using both the libraries, the functionalities are same. There is no difference in them. So we'll install these libraries first, and then we'll import whenever required. So first of all, I have to access the catalog. So for accessing the catalog, PyStack client is used. So I have imported client and the client.open. This is same as what we have seen it in the tutorial. In the same way, catalog URL, client.open, we pass the URL and everything. Same thing here as well. So we will load this URL. Then search parameters collection will go bounding box, your study area. Either you can pass your specific bounding box or you can pass on any GeoJSON or the shapefile or any boundary that you might have, load it and then pass it into the bounding box. Date and time, right now I'm trying to access only for a single year imagery, maximum item 10. I only want 10 items. So I searched it, then I want to see what was there in the items. So I'll print the length of the item. So there are 10 imageries because obviously maximum item I choose just 10. Dictionary keys, what is there in that data. So in that, these many bands are available in my data. And my required bands are NIR and red bands. So I'll use only those bands. Now I'm creating a cube. Either we can use ODC stack as we have already seen, and then or we can use stack stack. So stack dot stack, then we passed all the items in this, and then assets, I have to choose NIR and red band, resolution, and then bounds. This is important, bounds, and then EP coordinate system is important. That's it. Then we'll run the simple, no, okay, just a minute. We'll run the NDVI part. Why I'm not running this part? If you remember, this divide by 10,000 thing is for scaling. And when we get the data from the AWS and this Earth data, it is already scaled from 0 to 1. So that's why I'm not doing the rescaling part. But in case in any data you feel that scaling is necessary, you can do that. So I'm directly accessing the band stack.cell band red. From stack, I want to access the band NIR and then I want to calculate the NDVI. I calculated the NDVI. Then I'm just trying to print the minima and maxima value. That what is the minima and maxima value coming for the NDVI. This is just the warning. We'll ignore this for now. So minima is minus 0.099 and maxima 1.5568. That's fine. Now we'll calculate the mean and then plot the output. So NDVI.mean dimension is equals to time because I am removing that time dimension for now to calculate the mean. So that's why I remove. This is the syntax how we used to handle the X array. If you don't remember this, why I am writing dim is equals to time, you should watch the recording of X-array and when we handle the netcdf file. So I remove the time from doing the mean calculation. Okay, and then we got the final output, a single image for the whole year this time in this output. But in a similar way, you can also print multiple images, just like we printed here for multiple time period. You can also do that. Now we got the NDVI very quickly from that substack of data. So that was all about ODC and AWS Data Cube. So for your use case, I think all your purpose will be served just with AWS Data Cube. In case somebody is really interested in doing any project, specifically for your research project or anything, and you want to set up your ODC, so my first request from you will be to go through this documentation, understand what Open Data Cube is. Overview I have already discussed. And then in case if somebody is interested, we can take this up once your track 5 is over. But for now, I don't see any use as such to take 1 week of session only on this. Any questions, anybody? Now this whole track is completed. Only that Mapbox thing is left. We'll take a 1 hour session tomorrow on that. After that, it's completed. If there are any queries, anything you want me to take up, you can let me know. Else, it's fine. Okay, then we can close this session now. Let me know if there are any questions later. Okay, good night.